Hi everyone, so I'm doing roots and radicals part 2. I do want to go back. I made a mistake in the last video. I apologize, but if you go back to the bottom of the page here to number 5, the one thing I want to talk about, and we're going to talk about now, is this idea of absolute value when you take roots out. If the index is even and the power is even, then whatever you're taking out has to go within absolute values. So this would actually be 7. And the reason that if you think about that, if you do it first, you'd get the square root of 49, right? Which is 7. So let's look at this next step. We're going to add in variables, okay? So if I take the square root of x squared, we know that it's equal to x, okay? But since now it's even, we know that the index is even and this is even. Now we have to introduce this idea of absolute value, okay? So we're going to have to put absolute value symbols around that. So in this case, I have 25x squared. It would be 5x. We need the value to be, make sure we know that that value has to be positive because we can't put negative values under an even radical. All right, this one we don't have to, but x cubed means we want to take groups of 3's out. So this would be x, y squared. Why? Well, because there's 2 groups of 3, so y cubed and y cubed in 6. One trick is you can actually divide by the exponent, and that can help you. Okay, so for example, 4 here is even, and these are all even, so that means I'm going to have to use absolute value. So the 4th root of 16 would be 2. The 4th root of p would be p. The 4th root of q to the 8th would be q squared. Again, absolute value. I need all those values to make sure that we need to make sure that they're positive. All right, 5. We already actually know 16 is, so you really could write it like this, but I don't really, that doesn't matter to me. Okay, let's look at this next one. 5, x to the 10th, y to the 15th. Okay, so I don't have to worry about that because the index is odd. So I'm going to take 10, I'm going to divide it by 5. That gives me x squared. 15 divided by 5 is going to give me y cubed. All right, I want you to try 5, 6, and 7. All right, but hopefully you noticed they worked out nicely, right? Those were perfect nth roots. We're going to look at a little bit harder example in the next piece, but I want to go through this property for you so you can see it. So it's really important to recognize your index. That index does tell me a lot about whether it's a real or non-real answer. But if we have the nth root of a to the n, if n is odd, then the answer would just be a. Meaning if these are exactly the same, you'd be left with an a. But if n is even, then you have to remember that you're going to take the absolute value of the a. Okay? And we'll talk more about that in class. All right, but let's look at some examples that don't work out so pretty. Okay? Maybe let's think about what we used to do with 24. With the square root of 24, we would break it down into perfect squares. So I break that down into the square root of 4 times the square root of 6. So that would be 2 root 6. All right, but now the cubed root of 24, I have to think about what are my perfect cubes. So I actually write them for myself. 1 cubed is 1, so I don't worry about 1, but 2 cubed is 8. 3 cubed is 27. Okay? All right, so I can rewrite the cubed root of 24 as the cubed root of 8 times the cubed root of 3, right? Because 8 times 3 is 24. So the cubed root of 8 is 2, so that would be 2 cubed roots of 3. All right, let's try the next one. Cubed root of 54. I want to break it up by a perfect cube, okay? All right, so 27 is a factor of 54, so I'm going to write this as the cubed root of 27 times the cubed root of 2, because 27 times 2 gives me 54. All right, the cubed root of 27 is 3, so it would be 3 cubed roots of 2. Those index are important, guys, so let's make sure we write them. All right, when I now throw in variables. All right, I like to do it the same way. I like to think about how many groups of 3 I have here. So I'm going to do this 2 ways. If you think about it like this, that's what you have. You have the cubed root of x cubed times x squared. because we know power times the power, we add the exponents. So this would actually be x cubed root of x squared. Another way you could do it is you could divide 5 by 3. And the amount of times 3 goes into that 5 is the variable that's going to come out. So 5 divided by 3, 3 goes into it 1 time. So x will come out, and you'll have 2 left over that stay inside the radical, like that. Okay? All right, let's put one together here. 72 x cubed y squared. Okay, so 8 times 9 is 72, and I know 8 is a perfect cube. So I'm going to write, oh, it's a square root, sorry. Oops. All right, let's jump ahead. Let's save these for class tomorrow. Let's look at trying to put this together with the cubed root of 81, okay? So we know that we're looking for perfect cubes that are in 81. So I've got, let's see, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So that's too big. So 27 does go into 81. It goes into it 3 times. So that would give me the cubed root of 27 times the cubed root of 3, and then the cubed root of x squared. Now I'm doing this all out. Some of you are going to get really good at it, and you can see exactly what to do. All right, so this would give me 3 cubed roots of 3, and then this one, the cubed root of x cubed, would give me x. So that would be on the outside. Okay? All right, so we're going to stop there. We're going to go over these next couple examples tomorrow. We'll talk more about the absolute value. Okay? Have a great day.